All right, we're going to do some Notes 15 factoring this time. All right, and we've spent some time talking about factoring, so let's see what we got here. The directions just say to factor, so you're going to have to start knowing what kind of factoring you're dealing with. Now, I'm going to be honest with you. The first thing I'm always going to ask you guys to do is to look to see if you have a GCF. And when I look at these two terms, yes, I have a GCF. So I'm going to show what I am factoring out. For 4 and 6, I can factor out a 2. For x to the third and x to the seventh, I can factor out the x to the third. It's the lower amount of x's. And I can do the same thing for the y's. Y to the eighth and y to the fifth. I'm going to factor out a y to the fifth. Now, please, for the love of all that is good in your math world, do not lose that GCF. It is still part of your terms. It's still part of your answers. In fact, it is a factor, right? GCF, greatest common factor. Okay, so don't lose it. So then let's actually do some division here. 4 divided by 2 is 2. All the x's have been canceled, right? X to the third over x to the third. Now, y to the eighth, factoring out a y to the fifth, we're going to do quotient rule, which means we're going to subtract. 8 minus 5 makes 3 y's left over. Plus 6 divided by 2 is 3. We got another quotient rule problem here. X to the seventh over x to the third. Subtract the exponents, you get x to the fourth. And y to the fifth over y to the fifth is gone. They have factored itself out. All right, so there is the answer to part A. Let's slide on over to part B. Again, the first question I ask myself no matter what is, do I have a GCF? And the answer is I don't. All right, while parts of these have things in common, that's not going to be enough. It's got to be all three of these terms. So this is a trinomial, all right, and the way that I know to factor out a trinomial is guess and check, all right, but basically what it comes down to is we're going to split the x squared, all right, so we're going to split that x squared, and then I'm going to look for numbers that multiply to 12, and I want those same two numbers to add up to 8. If you know it off the top of your head, awesome. If you need a reminder of things that multiply to 12, you can just start listing out your factors. And I just stopped there because I just forgot. But also I could have stopped at 2 and 6 because those are the things that multiply to 12. And last time I checked, 2 plus 6 makes 8. So these would be the factors that I would be wanting to use. Now, I'm multiplying to a positive, I'm adding to a positive, so plus 2, plus 6. If you want to check, you're going to do x times x, x squared. 2 times 6 is 12. The inside terms make 2x. The outside terms make 6x, which adds up to 8x. Those are the correct factors. All right, so that's part B. Let's slide on over to part C. GCF first. Nope, there is no GCF. So let's move on into the factoring of a trinomial. This time I'm going to take the p squared term and split it. Each factor gets a variable p. Let's see, I am trying to multiply to a positive 24 and add up to a negative 11. So here's the thing. The only way to multiply to a positive is if the two signs here and here, whatever these happen to be, okay, are the same. So either two positives or two negatives. If I make both of these positive, there's no way to make that negative. So both of these numbers are going to need to be negatives. Now, again, if you know what it is off the top of your head, just fill in the numbers. If you are uncertain, you can, of course, start writing out the factors of 24. So 1 times 24, 2 times 12, 3 times 8. I can actually stop right here. There is another factor pair, which would be 4 times 6. But 3 times 8 makes me my 24. And if I make 3 and 8 both negative, that will add up to the negative 11. So negative 8, negative 3. The order that you write those two will not matter. Quick double check to make sure they haven't screwed something up horribly. First term times first term, that's going to be p squared. If I do last term times last term, negative 8 times negative 3 makes positive 24. Negative 8 times p, and then p times negative 3, which would be negative 8p and negative 3p. Those add up to negative 11. So yes, those are the correct factors for C. Moving on to part D, GCF, nope. So let's see, we're going to take our k squared, we're going to split it. I'm looking for things that add up to -4 and multiply to -32. We have mismatched signs here. So because we're trying to multiply to a negative, I'm going to need one negative, one positive. They've got to be mismatched to multiply to a negative. And I'm feeling like 8 and 4 are going to get me 32. And if I make that 8 negative and that 4 positive. So here's a double check. K times k, k squared. -8 times +4 is absolutely -32. -8k and +4k will add up to -4k. Those are the correct factors. Now for this one, I didn't write out the factors of 32. I knew them. It's great. If you need to write them out. All right, last part here for part E, and then I think there's two more below that we'll get to those. Part E here in this line, GCF, no, we don't have a GCF. All right, cool. So let's factor the trinomial, split the M. I'm looking for things that add up to 2 and multiply to -8. Now, there's so many different, it's literally an infinite number of combinations of things that add up to 2. We are much more limited to what multiplies to -8. So we're going to start there. So again, we're going to mismatch our signs. We've got a negative and a positive because that will multiply to a negative. And let's see if I do +4 times -2. Let's see if we check that if it works. So first term times first term, m squared. -2 times 4 is -8. That's good. So that's -2m or -2m, and then +4m. So 4 minus 2 makes the 2. All right, we have the correct factors. All right, so that's the top row. And I believe there's two more questions down here. There's an F and a part G. So let's talk about part F. Do you have a GCF? And the answer is, well, yeah, I do. All right, all three of these terms are all divisible by 3. So let's factor out a 3. X squared is left over. 6x plus 24 divided by 3 makes 8. Cool, you factored out a GCF, but you're not done. This trinomial can now be further factored. So we're going to leave the 3. We're going to split the trinomial. Okay, so we're going to split this x squared. So here's an x and an x. And I'm asking you to think of numbers that multiply to 8 and add up to 6. Not too many options here. I'm kind of like in 4 and 2. And if I do a quick check, x times x is the x squared. 4 times 2 makes 8. 4x plus 2x makes our 6x. So in this case, you have a combination factoring problem. You were able to factor out a GCF. All right, we factored out the 3. Love that. Still one of our factors. But this remaining factor was then able to be factored further. So please make sure you are completely factoring your problems. Okay, unless the directions say something like only factor the GCF, then you just keep going. All right, so let's move on. Last problem in this video, which is going to be part G here. It's the last factoring problem overall. And do you have a GCF? And the answer is yes, you do. All of these are divisible by 2. Do not drop the 2. Do not lose the 2. Okay, it is one of your factors, and it needs to be part of your answer. But now that you've gotten this GCF factored out, this trinomial is able to be factored further. So we're going to leave the 2. We're going to split the trinomial. So x. Let's see if we can find two numbers that multiply to -3 and add up to 2. It's got to be mismatched signs to multiply to a negative. And only one pair of numbers multiplies to 3. It's 3 and 1. You just have to figure out how to make the signs work. I'm going to go +3, -1, and I'm going to check it. So x times x is x squared. -1 times 3 is -3. -1x, +3x will definitely add up to 2x. So there are your fully factored expression. That's it for Notes 15. As always, let me know if you have any questions or concerns, and I'll see you in the next one.